Hello, pre-algebra. I'm here. We're going to do our notes today. So today we're going to talk about the mathematical properties, which are really the algebraic properties that you're going to see for the next couple of years here in your math career. We're going to really touch base on it. I'm going to kind of show you what some problems that might look like on your homework tonight, and hopefully this will be really helpful that you can stop and go and come back to this lesson. First thing I would like for you to do is I would like for you to fold your notes along this line. We're going to glue it in after we've done our notes. So in the middle of our notes, you can see here that we're going to talk about what is our kind of essential goal for the day. And our essential goal for the day is, can we identify mathematical properties of addition and multiplication? And I'm going to go ahead and highlight these because they're pretty important. I just want to be able to identify mathematical properties of addition and multiplication. And what kind of problems that you might see in your homework, and I'm going to type them, but you're going to have to write them, is you might see something like identify the property. And then within that, it might have something like 6 plus 3 equals 3 plus 6. And this is a really basic example, but within this, you have to identify that what is happening here. Another example that you might see is 9 times 1 equals 9. Or another example that you might see, and this one we're going to spend some extra time on Friday, is this one, where you have a multiplication problem. And we find out that this multiplication problem of 7 times the difference of x and 7 equals 7x minus 49. Now you might be able to identify what they are because a lot of this is a review. I know that I've taught this in 4th grade, I've taught this in 5th grade, I've taught this in 6th grade, I review it in 7th grade. Heck, even I review it with my intermediate kids in their 9th grade math course. So I know that you're going to see this over and over and over again for the next few years. So the more you can get it now, the easier your math is going to be in algebra and in intermediate. So you might be asking yourself, well, if we go over this so many times, why do I need to know it right now? Well, the reason that you need to know it right now is because we use these properties to solve equations and simplify expressions. Super important, and I spelled simplify wrong, I'm sorry. Super important for what we're doing in math. We use these properties to solve equations and simplify expressions. Hands down, one of the biggest things that you're going to do in algebra. And since you're in pre-algebra, you have to really understand them now. In algebra, you're going to need them again. In intermediate algebra, you're going to need them again. And then when you get to 11th grade and you're doing algebra 2, you're going to, guess what, use them even more. You kind of never get to escape these properties, so it's really good if you just learn them now. So let's go ahead and get on to the properties. There are 4 properties that we're going to talk today. The first one is the commutative property. The second one is the identity property. The third one is the distributive property. And the fourth one is the associative property. I know in our paper they go up and down, but on my computer it just makes more sense for me to do it right side up. So I'm going to go commutative to identity, distributive to associative. Now with the commutative property, when I taught my 4th graders this, I kind of taught them that the easiest way to remember the commutative property is that commute means to move. Commute means to move or travel. And I'm going to highlight that word move because that's pretty important. That's probably one of the biggest parts of this. So we're going to highlight that word move. Commute means to move. When my husband goes to work, his commute is from St. Paul to Rogers, Minnesota. When I go to work, my commute is from St. Paul to Roseville. Commute means to move. That's why we've got this school bus here. I hope that you can associate the word commutative to the school bus. You should probably highlight this root word there. Commutative means to commute, and commute means to move. So what it looks like. essentially our numbers move. The numbers move within the equation or expression. So for example, when we're doing our addition property, and I'm going to try to draw it here in a second, but when we're doing our addition property, we're saying in algebra, x plus y equals y plus x. Do you notice that my x moved from the other side? Now I might ask you, do you agree that 6 plus 2 is the same thing as 2 plus 6? They both equal 8. It doesn't matter which order I do them in. The 2 commuted from the end of the problem to the beginning of the problem, or the 6 commuted from the beginning of the problem to the end of the problem. This is an example of the commutative property of addition. Let's see. Oh, I can do different colors. So this is the commutative property of addition. This only works with addition. It does not work with subtraction. You learned in our second unit that 6 minus 2 is not the same as 2 minus 6. Another example of what this might look like is if I use the addition or the multiplication property of commutative. So that might look like in algebra, x times y is the same thing as y times x. Now in numbers, you might see that I might say 4 times 3 is the same thing as 3 times 4. Again, it doesn't matter what order I do it in as long as it's multiplication. So this is the multiplicative or commutative property of multiplication. You cannot use this for addition or subtraction and division. Cannot use for division or subtraction. It will not work. You will not get the same answer. That's a very important thing. You should highlight this. So, commute means to move. Let's move on to identity. The identity property is an important one as well. This one is your main goal of solving equations. And how we're going to remember it is your identity is who you are. What makes you, you? In math, it's what keeps numbers the same. So what you might see is something like in addition, with addition, we might see that we're going to add a 0 to keep the identity. It doesn't change. I can add 0 to any number and that number does not change. So for example, I might have with algebra x plus 0 equals x. With numbers, you might see something like x, oops, I gotta get my cursor back here. You might see something like 6 plus 0 still equals 6. It didn't change. So the addition property or the addition identity property is adding 0 to keep the identity. With multiplication, we're going to multiply by 1 to keep the identity. Oops, Identity. In algebra, that might look like x times 1 equals x. In real numbers, that might look like 19 times 1 equals 19. Super important, keep it in mind. Whenever something looks the same on one side or the other, it means it's the identity. Now we're going to move into the distributive property. There's a root word here. The distributive property's root word is distribute. The reason that there's a teacher here is because I want you to think about when I pass out papers. I distribute papers. I distribute them to every single kid in the class. So how to remember the distributive property is to remember that to distribute means to pass out evenly to all parties or to all people that are there. So what it looks like in math, and this is a hard one, is there's 3 steps. So there's 3 steps to a basic distribution problem. And I'm going to highlight what our key idea is or how we're going to remember this. So now, what distributive property means, and you should have seen this when you were in elementary school, is I might have something like this. 7 times x minus 3. Now, and I'm going to try to make this a little bit bigger. Nope, I got to go this way. We're going to make this a little bit bigger so that I can show you the steps. All right, so here we go. We've got our big problem, and I'd like for you to write it nice and big. And let's talk about our 3 steps. So our first step is that we are going to multiply, and I got to get a smaller font here. We're going to multiply this 7 times the x. And I'm going to move this. Sorry, my cursor is not going to let me do anything. So step number 1 is we're going to multiply the 7 by the x. So what that's going to look like, and we're going to try to do it here, is I'm going to show an arrow going from 7 to x. And 7 times x is 7x. We're just saying that it's multiplied. We don't know what the x equals, so we're just going to say that it's multiplied. And we know from our last 2 units that when they're squished together, that means multiply. So our second step is that we are going to multiply the 7 times the negative 3. And I don't know why it turned that to a 2 or a 1. I want that to be a 2. All right, we'll just go like that. All right, so now we're going to multiply the 7 times the 2. So I'm going to take this and I'm going to come all the way over here. And it's, 7 times the 3. And that's a negative 3. So 7 times negative 3, I have a positive and a negative. If I draw my sleepy nacho, I have a negative and a positive. So my answer is negative. I get negative 21. The third step is to check your symbols. Check your signs. We're just going to check and make sure that we've got, I don't know why it keeps numbering it to 1. Sorry, guys. So we're just going to check and make sure that our numbers are correct. Our signs are all correct. So I know that I have this negative, so I'm going to bring that down. That's all I'm doing is I'm checking. So what I'd like you to do is I want you to do one more example problem, and you're going to do it by yourself and then come back and check your answer. So here's your problem. Your problem is going to be, well, first of all, we're going to make it a little bit bigger here. Your problem is going to be 3 times 4 plus x. So I want you to go ahead and do this one and come back, and then I'll type the answer out. Go ahead and pause it and come back. All right. So you're back for your answer. Your answer is 12 plus 3x. Now, what's really important is that you remember with this distributive property, if you have a negative number outside of here, if we were to just toss a negative number right here, we have to distribute that negative number to both numbers as well. Sometimes you might even see a problem that looks like this. Negative times 4x plus 4. Now what this means is that I have to distribute this whole negative to each piece. I'm going to make this a little bit bigger. I need to distribute this negative sign to each piece. So when I'm looking at it, this negative is going to say, okay, negative times positive 4x. We're going to pretend there's a negative 1 right there. Negative 1 times a positive 4 is negative 4x. And this negative times a positive 4 here is minus 4. Really watch those negative signs. The last property that we're going to talk about today is the associative property. So with the associative property, we're going to remember that the root word is to associate. So how do you remember associate? Well, associate means who you hang out with. Whoops, not whoa. Who you hang out with. So to associate is who are you hanging out with? Who are you making your friends with? Who are you grouping yourself with? So who you associate with is who you hang out with. Who are you grouping yourself with? So what this property looks like is you are going to make numbers hang out by using parentheses. Okay. You make numbers hang out by using parentheses. Okay, so you make numbers hang out with one another by using parentheses. So yesterday and the day before, we really talked about order of operations. And in order of operations, you have to do what's within the parentheses first. So with the associative property, what's kind of cool about it is that you can change and manipulate with addition and multiplication by grouping things in different order or in different ways. So for example, I might say A plus B plus C is the same thing as A plus B plus C. And what this means is that notice my order didn't change. So there's no change in this order. I'm going to write that down. That's an important thing. Order does not change. So our order did not change. But what does change is how I'm grouping. So let's look at this with numbers. This might mean 1 plus 2 plus 3 is the same thing as 1 plus 2 plus 3. 3. It didn't matter which order I did, either the 1 plus 2 or the 2 plus 3, I'm still going to get 6 no matter how I do it. This also works with multiplication. So with multiplication, you might see A times B times C is the same thing as A times B times C. Now let's show that with multiplication or with numbers so that you can really see. What if I said 2 times 3 times, I'm running up, forgetting where my keys are. Well, what is 2 times 3 times 4? 2 times 3 times 4, I have to do the 3 times 4 first. So I get 2 times 12. And 2 times 12 is 24. Sorry, I'm going to space this so you can see it. Well, this is the same thing as 2 times 3 times 4. And what I mean by that is, now we have to do order of operations. So let's do the 2 times 3 first. We get 6. We're going to bring that 4 down. And then here I have 6 times 4 is 24. It didn't matter which way I grouped my numbers, I still got the same answer. This is another one that only works with addition and multiplication. Does not work with division or subtraction. Okay, your homework tonight is on pearsonrealize.com. I've assigned it through Google Classroom, so please make sure you check it and you can get to it. If at any time you were confused, I hope you stopped, paused, and came back. Please raise your hand when you're done and let me know that you're ready to move on. Go ahead and glue your notebook or glue this into your notebook. Have a good night.